All right, chain rule, differentiate the following functions. So for A, we want to just use the power rule. So the derivative of the outside function is going to be 6x squared plus 5 squared. So ignore what's inside. And then multiply by the derivative of the inside function, which is 2x. So we'll have 12x, x squared plus 5 squared. For B, the derivative of the outside function is going to be just 2e to the x squared plus 1, because derivative of e is e. And then we have to multiply by the derivative of the inside function, which is 2x. So we're going to have 4x e to the x squared plus 1. Number 8, so for A, derivative of this one, so it's just going to be e to whatever, just ignore it, and then multiply by the derivative of the inside function, which is -1. And then, we're going to have 8e to whatever, and then multiply by the derivative of that, which is 1/2. So we're going to have -7e to the negative x plus 4e to the x over 2. And for B, we're going to have the derivative of cosine is negative sine, and then multiply by the derivative of the inside function, which is 3x, just 3. And then plus the derivative of x is 1. So we're going to have -9 sine 3x, and then plus 1. All right, for number 9, natural log derivative is 1 over x. And in this case, x is x squared plus 1, and then we multiply by the derivative of that inside function, which is 2x. Derivative of cosine is negative sine, pi over 2x, and then times the derivative of the inside function, which is pi over 2. So if we simplify this, we're going to have 2x over x squared plus 1 minus, these 2's cancel, so minus pi sine pi over 2x. And for B, we're going to have, so this is like x squared plus 5 to the 1/2 plus x to the 1/3. So we're going to have the derivative is equal to 1/2, just by the power rule, x squared plus 5 to the negative 1/2 times the derivative of the inside function, which is going to be 2x, and then we're going to have plus 1/3 x to the 1/3 minus 1 is 1/3 minus 3/3, which is negative 2/3, and there's no chain rule for that, just times 1. So if we wanted to write this neater, we would have 1 over 2 square root of x squared plus 5. Oh, sorry, I didn't see that. So we have also 2x up top. So actually that 2 cancels. So this 2 and this 2 cancel. So we're just going to have x. And then we're going to have plus 1 over 3, the cubed root of x squared. Okay, that 3 comes out to the cubed root, and the squared stays in. All right, number 10. So A, f prime is going to be just power rule, 3 times 2x plus 5 squared times 2 plus, so that's the derivative of the inside, 2x plus 5 to the 1, subtract 1 from the exponent, times 2, and then we're going to have just plus 2, because the 5 goes away. And writing this neater, we're going to have this for 2x plus 5 plus 2. And we could factor out a 2, but I mean, it's unnecessary. All right, so I'll just rewrite this differently. So this is sine x squared, and this is cosine x squared. So derivative of sine is, well, hold on, sorry. Power rule first, so we're gonna have 2 sine x to the 1, and then we're gonna multiply by the derivative of the inside function, which is cosine. And then here, we're gonna have 2 cosine x to the 1 times the derivative of cosine, which is negative sine. So this is gonna be 2 sine x cosine x plus, so minus 2 sine x cosine x, so really the derivative is 0. All right, so now for 11, we've got product rule with some chain rule. So we're gonna have u is x and v is sine 3x, du is 1, dv is cosine 3x times 3 by chain rule. So we're going to have y prime is udv, so 3x cosine 3x, plus v du, which is just sine 3x. All right, and then b, we're going to have u is natural log x, v is x, and then du is 1 over x, and dv is 1. So then we're going to have quotient rule here. So y prime is going to be v squared on the bottom, and starting with v du minus u dv, which is just natural log x. So simplifying this, we're going to just have 1 minus natural log x over x squared. All right, number 12, differentiate. So we're going to have y prime is 2 x squared plus 1 to the 1. So that's the derivative of the whole thing times the derivative of the inside. So 4x x squared plus 1. Double I. So y prime, derivative of the whole thing is 1 over 3x minus 1 times the derivative of the inside thing, which is just 3. 13, so this is going to be 3 minus 4x to the 1/2. So for I, we're going to have 1/2, 3 minus 4x to the negative 1/2 times the derivative of the inside, which is negative 4. So we're going to have negative 2, 3 minus 4x, which I will just put on the bottom as square root of 3 minus 4x. Now for double I, the derivative of e is e, so e to the sine x times the derivative of the inside function, which is cosine x. All right, 14, if we want the derivative, we want e to the x over 3 times the derivative of the inside, which is 1/3. So that's that first term, and then we're going to have, so that's 5 cosine x squared. So we're going to have plus 10 cosine x to the 2 minus 1, and then times the derivative of cosine, which is negative sine. So just writing this better, we're going to have e to the x over 3 minus 10 sine x cosine x. 15, f prime, we're going to have 3 times 2x plus 7 squared times 2. And g, so g is going to be cosine 4x squared. So g prime is going to be 2 cosine 4x to the 1, and then times the derivative of cosine, which is negative sine 4x, and then times the derivative of what's inside of that, which is 4. Okay, so we have a function inside of a function inside of a function. So this is going to be negative 8 rather, cosine 4x sine 4x, and probably if we had sine 2 theta is 2 sine theta cosine theta. So if we have theta, so theta 2 cosine 4x sine 4x. So if we have theta is 4x, we can rewrite this as negative 4 sine 8x, because we have that theta is 4x. Okay, so 4x here. Okay, A16. So this is the second derivative here. So first derivative is going to be 1 over 2x minus 1 times 2. So 2 over 2x minus 1. And if we want the second derivative, we can rewrite this as like this. It's probably the easiest way. You could do also quotient rule, whatever. So this is going to be negative 2x minus 1 to the negative 2 times 2. So power rule and then derivative of the inside. So that's negative 4 over 2x minus 1 squared. All right, so we've got this function, find the derivative. So we're going to have 1 over 2x minus 1 times 2, and the value of x, where the gradient is equal to x. And the value of x, so we want to set this equal to x. So we're going to have 2 over 2x minus 1 equals x, and I'm just going to subtract x. Get it equal to 0. I guess we don't really need to do that. So we can just cross multiply. So 2 is 2x squared minus x. When you cross multiply, so we have 0, 2x squared minus x minus 2, and then 2x goes here, x goes here, and then we need 2 and 1, no, 2 and 1, and that's not factorable. So we're going to have negative b plus or minus b squared minus 4ac all over 2a. So 1 plus or minus 8, 16. So this is root 17 over 4. So that's the value of x, where the gradient is equal to x. So x has to be greater than 1/2. Square root of 17 is a little bit over 4, right? So if we add 1 plus a little bit over 4, this is going to be the answer we want, because if we subtract 1 minus a little bit over 4, that's going to be a negative number, which is not greater than 1/2. Okay, so this one I've already gone through in class. We've got the point P, 1/2, 0 lies on the graph of the curve, y equals sine 2x minus 1. Find the gradient of the tangent to the curve at P. So the first thing we did was we found the derivative. So we've got cosine 2x minus 1. That's the derivative of the whole thing times the derivative of the inside, 2. And then we have to find the gradient at P. The 0 doesn't matter, just the 1/2 matters. So we substitute 1/2 in. 2 times 1/2 is 1. Minus 1 is 0. Cosine at 0 is 1. And then times 2 is 2. Okay? And this is just for the tangent and normal line. I was just going over that. And then this one, I started it off. So we want to find the derivative and show it's equal to this. So I did derivative of sine is cosine kx, and multiply by the derivative of the inside, which is k. All right, so then minus, this is product rule, so we're going to have the first times the derivative of the second, which is negative sine kx, that's chain rule, times k, plus the derivative of the first, which is k, times the second, cosine kx. So then we just have to simplify this down. So k cosine kx. Actually, we're going to have k cosine kx minus k cosine kx. So those cancel. And then we're going to have negative, like the whole, nope, it's actually positive because negative is positive. Then we're going to have k squared x sine kx. Okay, 20. We have, consider this function, find first and second derivative. So I'm just going to rewrite it. Natural log x squared plus 4 to the 1/2. So I'm going to rewrite it again. 1/2 natural log x squared plus 4. Okay, so first of all, we're going to have 1/2. And then times derivative of natural log is 1 over x squared plus 4 times the derivative of the inside, which is 2x. The 2's cancel, so that's x over x squared plus 4. Then we're going to have quotient rule to find the second derivative. X is u, x squared plus 4 is v, dv is 2x, du is 1. So y double prime is going to be v squared on the bottom, and starting with v times du, which is 1, so that does nothing, minus u times dv, so that's going to be 2x squared. So then we're going to have x squared minus 2x squared, which is negative x squared, so 4 minus x squared up top, and then over x squared plus 4 on the denominator. And I think that's all you need to do. All right, so for 21, find the derivative of f at x. So we're going to have negative sine as the derivative of the whole thing times the derivative of the inside. For g prime, we're going to have derivative of natural log is 1 over, and then we have to multiply by the derivative of the inside. And now we've got h is f times g, find that. Okay, so if h at x is a function of x times another function of x, we're going to have product rule. So we're going to have the first f at x times the derivative of the second, which is g at x, plus the derivative of the first, which is the negative 2 sine 2x, times the second, which is g, so natural log 3x minus 5. All right, 23, we've got the derivative is going to be of e is e to the 5x times the derivative of the inside function. G is going to be cosine 2x times the derivative of the inside function 2. And then C, we've got product rule. So we've got the derivative of the first, which is 5e to the 5x, times the second, plus the first times the derivative of the second. Okay, so this one, we have f prime is going to be e to the negative 3x times negative 3, and g prime is going to be cosine x minus pi over 3. And there's no chain rule because you just multiply by 1. Now b, we've got h is f times g. So we have to do product rule. So we're going to have the derivative of the first times the second. Oops. Plus the first times the derivative of the second. And then we have to evaluate this at pi over 3. So we're going to have negative 3e to the negative 3 times pi over 3 is negative pi. And then we're going to have sine pi over 3 minus pi over 3, which is sine 0, which is 0. So this just goes away. And then we're going to have e to the negative 3 times pi over 3, which is negative pi. And then cosine pi over 3 minus pi over 3, which is cosine 0, which is 1. So this is just e to the negative pi, or 1 over e to the pi. So 24, the population is given by this function. Calculate when p is 0. So e to the 0 is 1, so p at time 0 is 100. And the rate of increase when the population is 10, so we want p prime at 10 is what they're asking. So p prime t is going to be 100 e to the 0.05 t times 0.05. And then the derivative at t is 100 e to the, if we're multiplying by 10, then it's going to be 0.5 times 0.05. And then this is 5 over 100 here. So this is just going to cancel. So we're going to have 5e to the 0.5.